So we're going to consider the function f of x equals negative 1/3 x plus a over 2x squared, where a is a constant and x is equal to 0, or not equal to 0. You're asked to find f prime of x, which represents the what?
Derivative.
Represents the derivative. So I have negative 1/3 x. What's the derivative of negative 1/3 x? Julia, what's the derivative of negative 1/3 x?
Negative 1/3.
Negative 1/3. Then I have to find the derivative of a over 2x squared. Christian, what did you get for that part when you took the derivative of a over 2x squared?
I got negative 2a over 2x cubed.
Very good. Because when you rewrite this part right here, okay, the 2 stays in the denominator, but then the x gets brought up with the negative second power, okay? Whenever you're moving variables up to the numerator, that's the only part that goes. The coefficients stay down in the denominator. So when we apply the power rule, we bring the negative 2 in front, and then we subtract 1 from our exponent, and that's still over 2. So then to make it positive, the exponent positive, we bring it back down to the denominator, and that's how we get 2a over 2x to the 3rd power. Are there any questions on that? So then we're told that the function f of x has a local maximum at x equals 3. Show that a is equal to negative 9, okay? We talked about this in the last class. Whenever you have a local maximum, what additional information, not so much about what it looks like, but what additional information do we also know if we're told that we have a maximum? Simi, what information do we know if we're told that we have a local maximum? Okay, online, Roderick, what do I know? If I know that I have a local maximum, what other information do I know?
The x coordinate of a point.
I am told the x coordinate of a point, but to help me show that a is equal to negative 9, what mathematical information do I also know? Olivia.
The f prime of x is 0. You can set it to 0.
The f prime of x is equal to 0. Because when the derivative is equal to 0, that means you either have a local min or a local max. That's what we talked about the other day. And more specifically, since it says that we have a local maximum at x equals 3, that means that when the first derivative, and I plug in 3, specifically it should equal 0. So that is how we show that a is going to be negative 9. By plugging in 3 into the derivative for x and setting the derivative equal to 0. What is 3 to the 3rd power times 2? What is that? 54. So this becomes negative 1/3 minus 2a over 54 is equal to 0. Then you need to continue to show the algebraic process to get that a is equal to 9 by adding over a 2a. And then you can cross multiply at this point. It's a show problem. So you're going to have to do the algebraic process. You can't plug it in to y1 and y2 and get a that way. You already know what it is. Cross multiply. That's negative 54 equals 6a. Divide both sides by 6. And that's how you get a is equal to negative 9. So, Roderick, Simi, when we're told that we have a local maximum or a local minimum, mathematically, what does that mean?
The tangent equals 0.
The tangent.
The gradient of the tangent.
The gradient of the tangent is equal to 0. And Simi, what does it mean when you hear gradient of tangent? What does that mean? Not a y coordinate. What is that notation, that f prime of x? What does that mean? It's the derivative. So the derivative is equal to 0. Even if you couldn't show that a was -9, you could have still done c and everything else below it. Find the y coordinate of the local maximum of the function. To do that, Peyton, how do I find the y coordinate? See there?
To find the y coordinate,
Mhm.
you would plug in the answer that you just got for x into the derivative.
Ooh, careful. You do need to plug the value of x in, but not to the derivative. If I plug the x into the derivative, it's going to give me 0 because that's where the maximum occurred.
Excuse me, this is the FTE. If you could please do.
By plugging in 3 into the derivative, we're going to actually find that it's going to be 0 because 3 was where there was a local maximum, aka where the tangent line of the slope of the tangent line was 0. So not the derivative, but the what?
The original equation?
The original equation. By plugging it into the original, we'll find our y coordinates. And remember, that's the only time we would use the original function. We would only use the original function to find any type of y coordinate. So plug in 3. I already plugged in -9 for a because that's what was given to me. This ends up being -1 minus 9 over 3 squared times 2. What's that?
18.
18. 9 over 18 reduces. So what's -1 minus 9 over 18?
It's -3.
-3
Over 2.
over 2. Here we go. So that reduces down to 1/2. -1 minus 1/2 is a -1 1/2 or a -3/2. Questions up to this point?
I put the one -1.5. That's good.
Yeah, -1.5 will work.
Okay.
This problem incorporates everything that we've done with calculus up to this point. In part D, it says sketch the graph of f of x for those particular restrictions. So you are, again, allowed to use your calculator the entire time. So what I'm going to do is I'm actually going to type in this function, and then I'm going to adjust my window so then that way I can see exactly what it should look like because it's a sketch. So I just need to make sure I highlight a few features of the graph. I'm going to delete all this other stuff. I'm going to delete this additional equation that I have here. And then I'm going to go to my window. I'm going to adjust my x min to -6 and my x max to +8 because that's what it told me the restrictions were for my x's. And I'm going to change my y's to -6 and +2 because that's what they told me my y should have been. Just double check on my equation, make sure I typed in everything correctly. That is a -9. Perfect. That, I think I used the wrong symbol, which I did. I put a minus instead of a negative, so that's good. I would have gotten an error message if I left that as a minus. So when I graph, this is exactly what we should be graphing. Why does it not cross over the y-axis?
X
Because there's a
cannot
vertical
equals.
asymptote.
Because there's a vertical asymptote there. X cannot equal 0. It told us at the beginning of the problem. So I want to make sure that when I draw my picture, I do the same thing. Okay? Got a mental image there. 2 of my wasps. 1, 2, 3, 4, 5, 6. One more time because I forgot. I got like a little, I got a little maximum like around 2, 3. Okay, make sure I stop before 8. And then, where did it cross the x-axis roughly? At what point?
-2.
Between -2 and -3. Okay, so I'm gonna do the same. There we go. Now it says state the values for x for which f of x is increasing. F of x is increasing. How do I know where a function is increasing? Anyone?
Whatever.
You have to get those test points.
I can get those test points. I can definitely do that. And I'm gonna kind of use the information that I already know to do that. I already know that I have a maximum at 3. If I have a maximum at 3, that means the sign diagram goes how? What on the left, what on the right? If it's a maximum.
Positive on the left and negative on the right.
So plus minus. This is my sign diagram from my first derivative. Remember, if it goes positive to negative, that means there's a maximum there. And since I was given that, I can use that information. And if on the first derivative, which one of these indicates increasing? The positive or the negative?
The positive.
The positive. So I'm increasing from everything before 3. Well, not everything before 3, because as you can see, y'all told me earlier that there was a vertical asymptote at 0. So because it's a vertical asymptote at 0, and as we can see on the left side of the graph, it's decreasing, it's going down. I'm only increasing from what number to 3? From 0 to 3. And I write in an interval notation with parentheses, because again, 0 is undefined and 3 is neither increasing nor decreasing. Questions on that?
Wait, my Wi-Fi cut out. So you just use 3 because that's the x value they gave you?
It's more specifically, it's the x value of a maximum. And in maximums, I already know that my sign diagram is going to be positive, negative there. So instead of using test points and basically being like pretty much doing what we've already know, I just went ahead and used the fact that it's positive, negative because it's a maximum.
Oh, okay.
But yes, that is what you would do if you weren't given that information. You would need to use your test points. Now I have to find my x-intercept of the graph. Jana, how'd you do that?
You go into your calculator and then you use your equation that you already have, and then you set the other one equal to 0.
What's
and
the
then
other? What do you mean the other one?
y2.
Okay, is that y2 equal to 0? Okay.
And then you'll go back in your graph and then do second trace, intersect, and then press enter 3 times, and then that will give you the x value.
Mm-hmm. But it's one thing to add. As you can see where my cursor popped up, I was on the left side of that asymptote. You definitely want to make sure you pop your cursor over to the left side. Sorry, I was originally on the right side, but I want to be on the left side because that's where my intercept is. Okay, so you always want to be closest to that intersection point. And like she said, click enter 3 times. So that's once, twice, and for the 3rd time, there is my x-intercept. So how do I round?
3 significant figures.
3 significant figures, and you cannot leave it exact. So my answer for F, where it says find the x-intercept of the graph of the function, it's going to be negative what?
2.38.
And it only asks for the asks for the x-intercept, so I want to make sure I write it as a point because x-intercepts are points. If it asks for the x-coordinate, then I just would have wrote down negative 2.38. Almost there. This is a perfect example for a paper 2 type question. It's covering multiple pieces of everything that we've done so far. Now for G, it says calculate f prime of 1. Guyena, what does that mean to calculate f prime of 1?
Would the x be 1?
The x would be 1. And then what do I do with that 1?
You plug it into your derivative.
Very good. So f prime of 1 means I take 1, I plug it into my derivative, which I found back in part A. I'm at part G now, okay? So I need to plug 1 into my derivative. Remember, A was negative 9. So 2 times negative 9 is a negative 18. A negative and negative make a positive 18. All over 2 times 1 to the 3rd power. Becomes negative 1/3 plus 18 over 2. What's 18 over 2?
9.
9.
So then when I do negative 1/3 plus 9, what is my answer?
8 2/3.
Okay. And what would that be as an improper fraction?
26 over 3.
I heard the over 3, but 2 people were talking at the same time. Say it, one person.
I don't know if what I got is right, but I got negative 28 over 3.
I got 26 over 3.
Should be the 26 because it was a plus 9, not a minus 9. And the reason why it was a plus is because when we plug in negative 9 in for A back up here, since it was already a negative in front or minus in front, a negative and negative make a positive. So it should have been plus 9, not minus 9. I'll say I'm pretty much out of space, but I'm gonna slide H along this side over here on the right side. Last but not least, I'm writing the equation of my tangent line. And to write the equation of my tangent line, I need, not the tangent line, I'm actually writing the equation of the what line? The normal. So in order to write the equation of the normal line, I need the gradient of the normal line, which is what?
The opposite reciprocal.
Of?
The answer that you just got in the previous question.
Very good. So then the opposite reciprocal of that, Dylan, would be what? All right, Isabel, what would be the opposite reciprocal of the answer I got in G?
It would be negative 3 over 26.
Negative 3 over 26. So then I need to use that along with a point to write the equation of my normal line. Well, I already know the x value of that point I'm going to use, which is 1. How do I find the y value?
You plug x back into the original function.
I need to plug x back into the original function. Gosh, everything's just tying in together just so wonderfully, so nicely. So if I plug 1 back into the original, that's going to give me a -1/3 minus 9/2 times 1 to the 2nd power. Somebody tell me what's -1/3 minus 9/2.
-29/6, I think.
Can I get confirmation? -29/6? Okay, I got a head nod up here. What you say again? -29/6. Okay, I lost it just that quickly. So now I can write the equation of my normal line. I am squeezing this in all on one page so everybody can see it. That might have been a bad idea, but y equals the equation of your normal, which is -3/26. Yep, it's not gonna fit. Gonna make this work. Going to make this work. I'm gonna take everything, but it is okay. Well, I'll be right. Okay. Y equals -3/26, x minus 1 plus my y value, which is a -29/6. When I distribute and combine like terms, that'll give me a -3/26x plus 3/26 minus 29/6. Can someone tell me what 3/26 minus 29/6 is?
-184/39.
Can I get confirmation?
Yeah.
Okay. And so then that'll be the equation of my normal line. And that is incorporating everything that we've done with calculus up to this point, except for formal definition. It's finding the derivative using our power rule in part A. It is finding or showing extrema with stationary points. That's when you set the first derivative equal to 0. That was what was in the orange in part B. It incorporated finding y values, which we did in part C and in part H. It was finding gradients, which was part G, by plugging in a value into your derivative. It was graphing, which really is like an old skill, okay? Just like writing the equation of a line is an old skill. You just have a new formula, which you guys did in part H. Any questions on question 4? So in D, the reason why, or E, the reason why it's not increasing from -infinity to 3 is because you have an asymptote on your graph. An asymptote is another critical point along your number line. It basically breaks up the fact that you're increasing and decreasing along your domain. Like it literally is, nothing exists at 0. So you can't use 0 because it will make the function undefined whether you're plugging into your derivative or to the original. Because if you try to plug in a test point as well, that's to the left of 0, like -1. If you plug -1 into your derivative, okay, which is in part A, that'll be -1/3 plus 9/2. That's going to give you a negative value. So those asymptotes break up your domain. They break up your intervals where you are increasing and decreasing. So if I were to use test points, you have to include asymptotes as well, because again, nothing is happening at those points. There's no increasing, there's no decreasing. That's why it's not -infinity to 3 where it's increasing. And plus we can also see on the graph On this part of the graph, what's it doing? That I just highlighted in tan.
Decreasing.
It's decreasing. So it wouldn't be positive, there would be negative. So not only do your stationary points go on your number line, but if you have an asymptote like here, you put those on your number line as well. I didn't necessarily have to do that for this one. I just need to recognize that there is a break in my entire domain. And it told me that from the very beginning in that first sentence.